Last and final video lesson. I know you're freaking out, but that doesn't mean you're done. That just means this is the last video, that you have learned everything you can in statistics, and now you'll have to do it on your own project. Okay. Hopefully you've downloaded this already. This is the Scatterplots Correlation Line of Fit and Predictions 10.1, 10.2 lesson. I teach chapter 11 and then I go back to chapter 10. But you should know this. This should all be familiar to you from Miss Davis, because she makes you do a project. I don't know if you remember that, like, I think it's fat grams versus calories project, and she made you go to fast food restaurants. That's where it's pretty much a similar thing. All right, so get your calculators out. Let's go. Let's get this ready to go. What are independent variables? Those are your x variables. Your x variables. Your dependent variables are your y variables. And again, remember, y depends on x. That's why y is the dependent. Y depends on x. That's your independent. There are 4 different types of relationships that occur between independent and dependent variables. You could have all your data points seem to go up. That would be a positive relationship. You could have all the data points seeming to go down. That would be a negative relationship. They could start to form a shape. We call that curvilinear. A curvilinear relationship. And then our last one, the dots could be so scattered that you would have no relationship. Last year, one of my students did a project on the size of your hand and of a football player's hand, I think, and if they made it to the Super Bowls, how many Super Bowls they made it to, and there was literally no relationship there. We knew it, but we were looking for something anyway. So we're going to do this example. We're going to show you how to do 3 different things to it. This is what you will have to do if you're comparing to see some kind of correlation going on in your project. So, for example, your math grade and your SAT grade. Is there some kind of correlation there between your grade in statistics versus your SAT grade? Or, the size of your shoe and your math grade? Obviously, there's no relationship there, but I'm just saying you're trying to find some kind of correlation. So I've already put this into my calculator. So we are going to construct a scatter plot for the data obtained in the study on the number of absences and the final grades of 7 randomly selected students from a statistics class. The data is shown here. So these are the number of absences and your final grade. So your number of absences would be your X. Your final grade would be your Y. You're going to make this your L1 and this your L2. You can type that in while I'm doing it. So looks like our highest is 15. 1, 2, 3, 4, 5, 15. And here we would have to, these are pretty tightly packed. You probably have to make a break and go. Oh, wait, somebody made a 40. Great. 40, 45, 50, 55, 60, 65, 70, 95, 80, 85, 90, 95, 100. Okay. And this would be your final grade. Again, you will have to, if you're doing a correlation project, you're going to have to give me this beautiful graph here. And I'm going to show you how to do it on the calculator, though, just so you can check and see if you're right. I've already entered this into L1 and L2. Okay. So we'll say that step number 1, stat, edit, L1 and L2. Step number 2, you are going to go to second y equals and you're going to turn your plot one on. So second, y equals, and you're going to turn your plot on, and you want it to be that first type. So we want it to be statistics looking. And then once you do that, you hit zoom 9. Now, if you have something else, let's see if I do. I didn't even clear it. Let me see if my y equals. I do. Look, I clear that out or else. So hit zoom 9 and look at all those dots. Okay, and you can graph them, obviously. 1, 2, 3, 4, 5, 6. I'll try to graph the first one. 55, 60, 60, 80, 85, 90. 1, 2. So 6 would go to 82. And you can keep the pattern going. 286. Something like that, okay? So what does that show me here? That shows me that they all tend to be going down. They all have this, there's a negative relationship here out of the 7 students that I chose. So there is a negative relationship. Meaning what? Well, meaning that the more absences, the lower your final grade. More absences, the lower final grade. Again, all things that you can say in your project when you have some kind of correlation going on. Now, let's just talk about this correlation because we're going to find out that there's a special number that we want to look for. Okay, and it's called the linear correlation coefficient. I'm going to show you how to get it on your calculator. There's a mathematical way of getting it, but we could just let our calculator do the work. The range for this linear correlation coefficient is from -1 to 1. Okay? If you have -1, 1, and then obviously in the middle would be 0. If you have -1, you have a strong negative relationship between the two, between your x and y variables. If you have a 1, you have a strong positive relationship. What do you think you have if you have a 0? That's right. You have no relationship. Okay, you don't want to get that. You definitely don't want to have a project where you have no relationship. Something needs to be happening. You should have picked a better category. All right, now, where do I get this lovely range -1 to 1? Where do I get that? I will show you in the next few examples. So let's finish this up. Find the equation for the regression line for the data in example 10.5 and graph the line on the scatter plot. Okay, so the equation for this regression line is actually called your line of best fit. It's the same thing, okay? And what you do, once you've entered in your data, you on the calculator, you're going to go to Stat, Calc, Lin, Reg, AX plus B. Now, most statisticians actually write that backwards. They like B plus AX. I don't need you to do that. So let's do that. Let's go to Stat, Calc, Lin, Reg. Don't go to Test, Stat, Calc, Lin, Reg. Okay, see they have Lin, Reg down here as A plus BX. That's actually, surprisingly enough, how the statisticians like it. All right, just do the one that you're used to doing with Miss Davis. L1 is your X, L2 is your Y. Calculate. And I get, it just says the formula again, Y equals AX plus B. I get A to be -3.6. So y equals ax plus b. Instead of writing a, I'm going to put in my value, negative 3.6. Negative 3.6 x plus, what's my b? 102.5, I'm rounding. Now, you should have seen these other two numbers come up. If they didn't come up on your calculator, then you need to go to your calculator right now. You're going to go to you're going to go to mode. And you're going to go all the way down here to where it says stat diagnostics. And you're going to make sure it's turned on. If it was off, that's why you didn't get those two numbers. Turn it on and then do the process again. Stat, calc, linreg. Enter, enter, enter. Okay, so r squared is 0.895, but r is what we're looking at. It's negative 9.94, r, negative 0.94. Write that down. Negative 0.94. Now, what does that mean? Well, again, looking at this right here, negative 0.94 is like right here. That's pretty strong. That's a strong negative relationship. There's some substance there then to this absences versus your final exam. Okay? So again, this is our correlation coefficient. We want to graph this line on the scatter plot. So you can do that, again, on your calculator. If you go to y equals, hit y equals, and then go to, I got to remember it. What is it, vars? No. Yes, it's vars. Sorry, I'm going to write this down. So go to y equals vars, then go down to statistics, which is number 5. Statistics. And then go over to EQ on top. And then go to regression equation. And what it did is it actually just pasted this formula, this regression equation, into my lovely calculator. And now I'm just going to hit graph. And that right there is the regression equation, or the line of best fit. Okay? And you can plot it on your graph if you're doing your project. So kind of goes like this. And that right there is the regression equation, y equals negative 3.62x plus 102.5. Okay? So I'm going to need to see that also in your project, this regression equation. Alrighty. So last and final thing. Use this regression equation in example 1010 to predict the final grade for a student who missed 4 classes. So this regression equation is so cool that you can actually figure out, well, if you miss 4, then what your overall grade could be. So what would you do here? Where would you plug in 4, for the x or for the y? Well, remember, 4 is the x. That's our independent. We plug it in right here. So we would have y equals negative 3.6 times 4 plus 102.5. So negative 3.6 times 4 plus 102.5 is 88. They would probably get about an 88% then in my class if they missed 4. That's pretty cool. Now, some other things to just take note. If you have a scatter plot and most everything is going down, but then you have this one random thing over here, okay? That random is an outlier, obviously. It's what we call an influential point. It's an outlier. It's going to obviously skew your data, but it happens, okay? But all it will do is, again, it'll move that regression equation. And then another big word is called extrapolation. In statistics, when you extrapolate, you make predictions that go beyond the bounds of your data. You make predictions that go beyond the bounds of your data, which is pretty cool because then you can, say, all right, well, if I'm going to be absent 12 times, I could figure out what my grade is. And it's using this information that this equation, this very important equation. Okay. All right. Hopefully this helped. Should be all review. You're going to do page 5, 7, 11, 18, 22, and 27. This is your last homework. Actually, you got a study guide and you'll take a test. And then from then on out, you are just going to be working on your project. Okay. You did great, guys. Bye.